Thank you. I'm Dave Nelson from Eli Lilly and Company, and I'm presenting on behalf of myself and Sue Wong Jacobson, and we thank SAS Global Forum for the opportunity to present our SURVEYCORRCOV macro for complex survey correlations and multivariate analysis and data modeling. My opening story is that I love new SAS PROCs. When there's new SAS PROCs, I get so excited. And not only do I want to learn about the new PROCs, I want to use them right away. My extreme example is when SAS introduced PROC inbreed. You may not even know that SAS Stat has something called PROC inbreed. But when I first saw that, I got so excited that I thought to myself, I have elephant family tree data. I can calculate the inbreeding coefficients in this population. So that's, I had the same reaction when I saw the survey PROCs. When SAS survey PROCs, like survey means first were introduced, I was just interested in these new PROCs. And so I started reading about them. And about 3 paragraphs in, I thought, never mind, I'm never going to use those PROCs. Well, fast forward until today, and about 95% of my work is the analyses using the SAS survey PROCs. So you never know where your career is going to take you. So that helped motivate our desire to have a macro that helps extend complex survey data to more analytic opportunities than is currently in the SAS system. So we will introduce a bit about complex survey data. We will discuss how the SURVEYCORRCOV macro works, and it creates output similar to PROC CORR, but it uses also the ability to output data matrices for both regression and multivariate methods. So complex survey data is an important source of real-world evidence. It's often designed to be nationally representative, and it's processed with embedded data quality checks. Because it's often free of charge, it's popular among students for research projects, theses, and dissertations. In fact, I've helped 4 of my colleagues with their dissertations and theses for epidemiology graduate degrees. Unlike data collected through simple random sampling, which is what we do most of the time, analysis of complex survey data must take into account the sampling design, and also the details of this kind of approach are well described elsewhere. Several textbooks will describe the methods to deal with that. I won't do that here. But too often, people use complex survey data and they do not properly use the correct analytic techniques for complex survey data. So we recommend 3 checklist steps as the foundation of analysis for complex survey data that create both unbiased estimates and proper standard errors. The step 1 is always use the survey procedures in SAS, for instance, survey means and survey FREQ. Always use the cluster, strata, and appropriate weights for your data. For example, in NHANES, there's several different weights. So if you're using only the questionnaires, use the interview weights. And if you're using laboratory values, use the exam weights. So that is the base, just to make sure you're using the appropriate weights for the analysis you're performing. Also, do not delete observations. Typically, in most times, if we want to analyze only the diabetes patients out of a data set, we only remove those patients and create a cohort. But in complex survey data, do not use by or where statements to subset your data. Create an analytical subset for use as a domain, which is analyzing the subgroup alone. For instance, if you only looked at a certain disease state, you may have empty strata, and that would affect the standard errors. So why did we create this macro? Well, SAS does provide complex survey univariate analyses like survey means and survey FREQ, and multivariable analyses, SURVEYREG, survey LOGISTIC, and survey PHREG, and also imputation, survey impute, and a really powerful tool, survey select, which can be used for a wide variety of tools. But within SAS Stat, multivariate analysis and multivariable model selection are not part of the SAS complex survey analyst toolbox. So our motivation is twofold. First, to construct a macro that mimics the key features of the PROC CORR procedure, such as creating a pairwise matrix of correlations and p-values, and we also provide an option to use ranks similar to a Spearman correlation. Secondly, I think our main motivation is that we can take those correlations and covariance matrices from this procedure, from the macro, and then input them into other SAS procedures such as PRINCOMP, Factor, VARCLUS, CAN, CORR, and REG, which will expand the toolbox for complex survey analytics. So these are the special data sets in SAS that can be input into procedures and the procedures that will take them. So I highlighted the CORR, COV, and some squares and cross products matrices. Those can be input into the procedures that are highlighted here. For instance, principal components analysis, typically you put in your data set, but really the analysis starts when you're at the correlation matrix or covariance matrix stage anyway. That's really when principal components begin. So if we can take survey data and then generate the covariance and correlation matrices, we can go straight into some of these SAS PROCs and be able to use complex survey data with their capabilities. This is kind of under the hood of how the macro works. The key thing is that it uses SURVEYREG, but I'll go through some of the steps. The main thing that we're outputting are correlation matrices, covariance matrices, and some of squares and cross product matrices. So the idea is that if you want to use a rank-based analyses, it will use PROC ranks to generate within domain ranks. But the key thing is it inputs the data into SURVEYREG and generates a matrix that's an option in SURVEYREG called the XPX matrix. That is a weighted sum of squares and cross products matrix. So if that is output, then that can be my final endpoint using the macro to generate that matrix. But it will then put it into PROC PRINCOMP and generate a covariance matrix or a correlation matrix on your data. We have another option I'll describe a little bit more later called out P4REG as a data set selection. And that adjusts the sample size to use in PROC REG, and I'll describe that a little later. The main thing from the ability to create a PROC CORR type of output is pairwise univariate PROC regs of each pairwise set of variables that you specify and the p-value from that. And that is extending. Jessica Hampton had done a previous SAS paper called PROC SURVEYCORR, and we're extending that to generate matrices and the ability to extract the matrix for other purposes. So this is an example macro call from using the SURVEYCORR COV matrix. So you'll see that there's various options to include your data set, your typical survey characteristics such as the strata, the cluster, and the weight, the domain statement, and also the variable names. All of the examples we're going to show today and also in our proceedings paper are using the Medical Expenditure Panel Survey, the MEPS data, which is a publicly available complex survey data set available regarding U.S. healthcare utilization and cost. So this is the PROC CORR type output based on using SURVEYREG R-squared values, reducing them to what we typically see in PROC CORR output. And there's two output options. You can either output them to your listing file or in Excel. There's an option to save all of your data sets in Excel. And so basically this is the output that you can see that's similar to PROC CORR. These are correlations of 3 MEPS variables. But the key thing that we find interesting is the ability to use those matrices for other purposes. And so this one shows the steps that for using for regression analyses, P4REG I had mentioned previously, that creates a correlation matrix that is adjusted, a sample size that's adjusted for using in PROCreg. So we used an analysis for the MEPS variables as independent variables, and just show across the different results to show what the macro data sets can do. The SURVEYREG output is what you'd expect from the typical PROC SURVEYREG analysis that adjusts for all of the complex survey characteristics. So you can see we have 3 independent variables and their parameter estimates, the standard error, the p-values, and also a column for the design effect. So if I used directly from the macro the correlation matrix, what I call out P from the macro, that will generate, you'll see the same parameter estimates are available from SURVEYREG and using PROCreg with that correlation matrix. But you'll see that the t-values are much higher, and so the reason that is that if you use the out P matrix, it will use a sample size based on the weighted sum of the population. So for instance, if you're using the entire US, your sample size was estimated as being 300 million, which is not the correct assumptions for generating the standard errors. So it's providing the right parameter estimates and standard, but not the correct standard errors. So what we did was we have an option called out P4REG, which is basically an output correlation matrix for regression for PROCreg. And basically it divides the sample size by the design effects that are shown in the SURVEYREG output. So what the impact of that is that now I have an adjusted sample size. So I can go into PROCreg and run the analysis, and you'll see that the parameter estimates, again, still the same, but the standard errors are much smaller than if I had just used the PROCreg results for the correlation matrix. So as you can see, they're not exactly the same as PROC SURVEYREG, but they're what I would consider a conservative result, so that all of the standard errors are at least as small or a little slightly larger than that from SURVEYREG. So that ability to be able to use complex survey data, generate a correlation matrix that go into PROCreg can yield some important information. What we have in more detail in our SAS Global Forum Proceedings paper is how to use PROCreg. We already have PROC SURVEYREG. Why would we want to include information on from PROCreg? Well, there are lots of things that PROCreg can do that PROC SURVEYREG can't. For instance, if you have a lot of variables that are correlated, the calculation of variance inflation factors to evaluate multicollinearity is one thing you can do in PROCreg with the output data. Also, there's an example in the proceedings paper of how we used ridge regression to within an output correlation matrix from the macro. And also, we have an example of how to use variable selection. Again, that's not available in any of the SAS survey PROCs for complex variables, but we do have as an example with selection equals CP to show how PROCreg can be used to provide informative information for analyses for complex survey data. Again, the final analysis should always be using SURVEYREG. These are only pieces of information that can help you as you build your final model. In addition, we have an example of a different approach to building a multivariable model using variable clustering to identify the independent variables for a multivariable regression. And that's also featured in the proceedings paper. Next, we also have so many opportunities to use these output correlation and covariance matrices from the macro to do multivariate analysis. And one of those is principal components analysis, which is a really valuable tool for what is called unsupervised learning when there's no dependent variable. Principal components analysis creates an uncorrelated linear combination of variables, starting from principal component 1, which accounts for the most variability, and then sequentially through to principal components that eventually equal the number of original variables. So there are options, and when you do principal components analysis, the default is the correlation matrix. So the correlation matrix is often very helpful when you have variables of different scales, of different types of measures, because it really reduces all variables to their standardized form of a mean 0, standard deviation of 1. But we're looking at medical expense types from the MEPS data set, and all of them are in dollars. So the available information is that that we could, instead of having standardized variables, we could use the covariance matrix to analyze the data and provide information from So the covariance matrix is accounts for the actual variability of the data points, so that it uses the variability of the actual data rather than the standardized variables. But you can see in this example, inpatient stays dominates principal component 1, because inpatient stays is such a variable measure. Most people have $0 for inpatient stays. Many people have over $100,000 for inpatient stays. That variability then dominates the covariance analysis of using the covariance matrix. So probably the best solution is using the covariance matrix for using a log transform first, because then that uses the correlation, the covariance matrix, but it uses the relative variability and not the variability of the entire sample, but just the relative variability. So you can see in that case, principal component 1 is much more balanced rather than the results from just purely the covariance matrix. And one of the things I think is the best way to view principal components is the way that PROC SURVEYREG can provide a mosaic type plot of the points. Since we're looking at survey data, I think the best way to look at distributions is using this kind of mosaic presentation, which will basically show that the areas of high red are the highest values, and of the most people are in that area. So then the PROC SURVEYREG can create these principal components and graphics that provide that information. There are other examples in the PROC survey in our proceedings paper. There are examples where we use PROC factor to do exploratory factor analysis. We also use PROC CORR to do canonical correlation analyses, maximizing the correlation of a linear combination of one set of variables with a linear combination of a second set of variables. And so we have more details in the proceedings paper. So in conclusion, we wanted to replicate the survey-based analyses in PROC CORR and as a conduit to other procedures, and that's why we created the SURVEYCORRCOV macro. We hope this macro helps run the types of analyses performed with complex survey data. We encourage any comments, questions, and problems and experiences with the macro Particularly, we don't have much experience using PROC Caylus, but if someone wants to use this with PROC Caylus and give us some feedback on how the analyses using the correlation matrix from PROC Caylus works out, we'd love to hear about it. Updates in the current version of the SURVEYCORR macro are maintained at that GitHub site. This is my contact information. Like I said, please contact me if you have any questions or comments about the macro. Thank you again for SAS Global Forum for allowing us to present at this time.